How would you differentiate between dark matter and dark energy?
95% of the universe seems to be dark matter and dark energy.
But dark energy is truly repulsive. Dark matter pulls things in, but dark energy has an anti-gravity character to it. It pushes things outward.
I get a call. I need you to point at this part of the sky and tell me what you see. And there were 7 puffy balls in a row. I'd never seen anything like it. What on earth is that? I traveled with Adam Gilchrist, the very famous Australian cricketer.
I've been very fortunate to have some communication with Mohinder Amarnath.
I think the hope is maybe we can think about how to engage cricketers, Australia and India, to talk around science for our collective good.
Movies serve to inspire our imagination, but we shouldn't take things literally.
Is Interstellar meant to be a piece of astronomical curriculum, or is it meant to be entertainment?
Good evening, Brian and Raja, and welcome to this podcast series. It's so good to have you here at Ashoka University. The idea of doing this podcast is mainly to have a conversation with people like you who have done so much in life, achieved a lot, but also want to give back, and also trying to see how to nurture a younger generation with the same kind of spirit, the same kind of ideas that you've had. So, you both are coming from such an area which is so popular, so fascinating, yet very mysterious. So, which is dark matter and dark energy, which is kind of the dark side of the universe, but it also has a lighter side. So, just to understand a little bit of it for a lay audience, how would you differentiate between dark matter and dark energy, just so that we can get the conversation going?
I use a one-liner when I talk to my students about it, and that is dark matter sucks,
Yeah.
but dark energy is truly repulsive. They have opposite effects. Dark matter pulls things in. Gravity of dark matter works just like the gravity of ordinary matter, the gravity of the sun, gravity of the earth. But dark energy has an anti-gravity character to it. It pushes things outward, and they're on the right-hand side of Einstein's equations of general relativity. They have opposite effects.
So 95% of the universe seems to be dark matter and dark energy. As Raja just said, they have these competing effects, but they're unified by the term dark. And the reason they're called dark is because the only way that we know they exist is by seeing how they affect the universe on large scales. We can't detect them here on the labs, here on Earth in labs, at least yet. So we'd love to, but at this point, we only know about them through astronomy.
I see. Interesting. So, in astronomy is such a field where sometimes you don't know what is the applied part of it, because when just governments or funding agencies, they pump in money for healthcare. I think this is something which is easily understandable because this is a question of our existence. But when they spend so much millions of dollars or euros into funding research in astrophysics, especially when it comes to expansion of universe, understanding galaxies, how is that related to one's own existence? Why is so much money pumped into it? Why do you do research at all in that?
It is not probably immediately apparent
Yeah.
that astronomy ends up being great value for the taxpayer, but it is. And it's because research and translation into products is an ecosystem. And if you only try to research things you already know, life gets pretty boring and you don't get the revolutions that we see that have, catalyzed humanity over the last 100 years or so. And so astronomy is part of the foundations of research that helps open up all sorts of new ways of thinking of things. And you just have to look at your iPhone to understand the effect of the astroparticle physics things we're talking about today. So when you look at your iPhone, you can start with the World Wide Web and the touchscreen both came out of CERN because they were trying to solve problems at CERN and they needed to develop new things. You can look at the GPS, which involves precision clocks that were useful in astronomy and in areas of physics that you could then stick into space and use general relativity to figure out where you are on Earth really accurately. You've got Wi-Fi, which has come out of radio astronomy in Australia. You have the detectors, the CMOS detectors, which come out of a NASA mission to Jupiter, where they needed to create a low energy digital imaging camera. So those are most of the things that make the iPhone what it is today. And they all came from seemingly useless astronomy. So astronomy and astroparticle physics. So you really need to create a slew of ideas and people who know how to use those ideas, and innovation comes from that. You don't just say, let's do the good stuff, and magically people invent an iPhone. It's not how it works. It comes from a highly creative process of which astronomy is emblematic.
I just want to riff off some of the things Brian said. I mean, instead of isolating astronomy and astrophysics as a subject, if you look at the parallels in what imaging technology does for astronomy versus what it does for medical imaging, these developments shouldn't be treated in isolation. It's inefficient to treat them in isolation. It's much better if you treat these two seemingly disparate fields as if you treat the technology together, if you think of the technology together. Coming back to something you asked, it's some of these questions are related to our very existence. Some of the biggest questions we can imagine, in spite of our how tiny we are relative to the universe. That itself is such a magnificent thing. Thinking, astronomy fills us with a sense of humility and fragility, but also it's remarkable that we can contemplate things that are so much bigger than us. And I also think that astronomy, like so many other fields, is a gateway drug to critical thinking, and that critical thinking is the key thing. And what that's going to lead to is unpredictable, and there's beauty in that unpredictability and the discovery space that it opens up.
Okay. Yeah, so I think there are so many spin-offs which is coming from astronomy, and as well as there is a way of connecting, understanding the history of our past and sort of also predicting the future in some way because that has to got to do with our existence as well, right? So
yeah, and another feature of astronomy is it's global.
Yeah.
No one owns the sky. It's shared by everyone. It's something that humanity has managed to rally around literally for our entire existence. So we can still have, Russian and American scientists studying space work together, even though we can't work in any other area. So it really is also a global commons in a way that no other real subject has managed to do for hundreds of years. So it has another aspect around it as well.
Right. Interesting. So the other thing is about, the mystery. As I said, astronomy is also very mysterious. So when you talk about, especially Brian, your work on the expansion of universe, and you say that universe is expanding at a rapid rate. So how is that, impacting, our lives, or how are you going to explain this concept to somebody who's not an astrophysicist?
You have to take people through the history of how we got to where we are today. And what is beautiful about the story of the universe is it's actually quite intuitive. It's got a couple surprises, but it's quite appealing. And it sort of makes sense when you hear it. It's a surprise, but I do think it's something that most people can kind of go through and go, wow, that is the universe I live in. Isn't it amazing that, as Raja said earlier, we're a tiny little speck of everything there is, and yet from here, we're able to understand literally everything there is. Now, there are still some mysteries, but we really are beginning to understand our place in the universe very well. And I think that's quite empowering and captivating And I think in the end, it's a story that gets people in a positive motion about what humanity can do. And we have a lot of problems to solve, and being positive, not a bad thing right now.
Yeah, and also humbling, I think, right?
It's also humbling when you
Yeah.
realize just how
Yeah,
minuscule we are and the universe really doesn't care about us.
yeah.
I think that's useful to know as well.
Yeah, yeah. And Raja, you went away from our galaxy to Andromeda. So why did you pick up Andromeda, and what is so fascinating about that?
So one of the bad things about studying our own galaxy is we're stuck inside it, and we don't have a long enough selfie stick to see ourselves from the outside.
Yeah.
Andromeda gives us that vicarious selfie stick. We can see individual stars within it,
I see.
but we can see the entire home at once. It's the analogy I think of is if you're stuck in the bedroom of your house for your entire life, and your walls are translucent, you can see into the next room, but you can't really see through the house. You don't know what your house looks like from the outside. Your best bet is to look out of the windows of your bedroom, the same bedroom you're stuck in for life, and look at other homes nearby,
Yeah.
and that gives you a sense of what your own home looks like from the outside. And that's you hope you live in a condo complex and the houses are similar, so that what you're learning from your neighbor's house tells you something about your own. That's what Andromeda is to us. It's a neighboring home.
Yeah, I think that's a very interesting perspective, and why we should just look beyond ourselves and beyond what we do. So, okay. And also, a lot of people study about exploding stars, for example. And then how is that, again, impacting the universe, or why are those studies important?
Well, we're always trying to understand how we got here. So we're sitting here and we're seeing material that is stuff that is not hydrogen and helium.
Right.
And we know the Big Bang made hydrogen, helium, and not much else.
Yeah.
So what made the carbon in the plant that's in front of me? What made the oxygen in the water? Well, it turns out exploding stars made most of it. And trying to understand the story of the Earth, of the universe, means understanding how the elements were created in it. And supernovae are how many of those elements are made. And it turns out understanding the supernovae have all sorts of interesting ramifications, because one of the things maybe not covered in the movie Oppenheimer is, what did Oppenheimer study? Supernovae, right?
Yeah.
So he studied the same thing I study. So it turns out there are terrestrial aspects, maybe not all good,
Yeah.
that connect to these massive stars and how we understand them.
I see. So, I'm just curious to know that while you were making your observations, or, extracting data from telescopes, is there something that, if you can sort of give an example of one surprise element that came across and you were like, wow, I didn't even imagine something of that sort. What would that be?
I'll give an example. I was out observing supernovae, I think 1994, and I get a call from a guy by the name of Brian Marsden, now passed away, but he was part of the IAU circular that goes through and looks for comets
Okay.
and asteroids. And he says, I need you to point at this part of the sky and tell me what you see. So I go, okay, what am I not? Took a picture, and there were 7 puffy balls in a row on the image. I'd never seen anything like it. And I was like, what? I literally called him up and said, what on earth is that? And he laughed. He said, oh, it's real? And I'm like, what is it? And he
Yeah.
said, well, it looks like a comet that went by Jupiter and broke up into kind of a string of pearls.
Gosh.
I need you to immediately give me all the positions of these things. So that turned out to be the confirmation image of the Shoemaker
Levy 9.
9 comet.
Oh, wow.
And as I said, I just was looking, and I think he did not expect to see anything. But when he heard me go, what is this thing?
Yeah, yeah.
He knew it was real. So that was a surprise.
Interesting. So, Raja, when you were looking at, stars and looking at the the passage of time, through the cosmic time, and you sort of get a little bit of information about the history. So do you think that you are at a point where you can sort of recreate this history and then sort of present the whole story? Is that something that you do?
You do. The kind of research I do in Andromeda, you're not looking very far back in time. In terms of cosmic time, Andromeda is only, I'd
Yeah.
say only 2.5 million light years away.
Right.
So the stars the light of the stars we're seeing have been traveling only for 2.5 million years. I say only because the universe is more than 1,000 times older than that. It's 14 billion years old.
Right.
And this is
Right.
only 2.5 million with an M versus 14 billion with a B.
Yeah.
So it's not that look back time that's important. Rather, those stars that we're seeing were born easily. Some of these were born another 10 billion years, 10 billion years before before the way they are now.
Right.
So it's that kind of fossil record approach to things that, long after dinosaurs were born and ruled the earth and died off,
Yeah.
their bones can tell us something about how the earth was and how they were when they ruled the earth. And in this sense, what we see in the fossil record of Andromeda and the Milky Way are events that took place easily 10 billion years ago. We're seeing the remnants of those things. So the term fossil record and archaeology is often used in the context of this kind of galactic study.
Oh, I see. I see. And because again, astronomy and astrophysics is because of the mystery, there are a lot of myths around it. So when you actually talk to public or generally interact with anybody in your family or friend circle, do you think there are some common myths about astronomy or astrophysics that you've heard and you said, no, no way, that's not how it is going to happen?
Well, there are many misconceptions.
Yeah.
So one of the biggest misconceptions is black holes.
Yeah.
Okay. So, if the sun suddenly, by divine intervention, turned into a black hole right now, the sky would turn dark, but the Earth would continue on its orbit absolutely unchanged because the gravity of it is the same. Okay. So people think that black holes hoover things up.
Yeah.
Well, they don't hoover things up any more than the sun does. You can get a lot closer to a black hole than you can get to the sun.
Yeah.
So some really crazy things can happen that can't happen around something like the sun. But the black hole itself, its gravity is the same as the sun. So I think that's a classic example where people get things wrong based on just the way things are portrayed in the media, for example.
Yeah. Yeah.
Another thing I've encountered a lot, especially when people find out I grew up in India, the conflating astrology with astronomy. One of those is predictive science, and it has a certain pathway through which you study it. I know very little about astrology, so I don't want to say anything about how it's studied. I don't know very much about the pathway you follow to study something like astrology, but they are wildly different. And I know I've studied one, I know nothing about the other. So much so that I've taken to not using the term astronomer anymore because I'll get mistaken for astrologer. So, saying you're a cosmologist or you study the universe or astrophysics is a safer.
But then you have the age-old problem of cosmologists and cosmetologists.
Oh, yes, that's true.
So one's cousin hair, which I know nothing about except for, otherwise. So, it's danger at every direction.
Yeah, cosmetology and cosmology are both about the effects of time and gravity. So that's
Yeah, that's true. In different scales, I guess. So, one thing is that you said about black holes and these misconceptions. A lot of it is coming from media, through cinema, through I don't know, many of the things that's made, projected, and many of the students, adults, everybody actually watch these movies, right? And there's like Interstellar, Gravity, so many of them which are very famous and is watched globally. So, how much of that should people actually take in? What percentage of that should be something which they should see with fiction, or say that okay, that is real?
Well, I think cinema, uh, even those that try really hard, like Interstellar,
Yeah.
and just to be clear, Interstellar
Yeah.
hired Kip Thorne's group. Kip
Yeah.
Thorne won a Nobel Prize later on
Yeah.
to do some of the calculations. Even with all that effort, then they took some license, which was completely
Yeah.
not of our universe.
That's like
Right.
artistic freedom kind of a thing.
That artistic stream. So I guess what I would encourage people is to be critical about what they see in terms of, is it real?
Yeah.
Some of it is genuinely pretty real. But right next to it will be something that's ridiculous.
Yeah.
So at some point we have to decide, is Interstellar meant to be a piece of astronomical curriculum,
Yeah.
or is it meant to be entertainment? And it's clearly the latter.
Yeah.
Ideally, we try to embed some stuff where, without any harm to the the cinematic uh, uh, desires of, Christopher Nolan or whatever, that you can teach people along the way.
Yeah.
But I'm here to tell you, it's a pretty rocky road, and I don't think we're going to change it as much as I would like. And I have a desire to embed real physics into video games, because I actually think you could probably teach people physics through video games with absolutely no detriment to the plot. But no one at this point has really done it.
But Raja, weren't you involved in some gaming activities?
I got consulted for a video game
Yeah.
that I've never played. I don't play video games, but I was consulted for something called Mass Effect. And one of their, it was between the third and fourth edition, there was something called Mass Effect Andromeda.
Right.
I was very happy to see that, they did a little interview about, fact-finding about Andromeda. And at least what they wrote down from that interview was super accurate. They paid a lot of attention to detail. They understood, what we discussed about what's known and what's not known about Andromeda. I was very
Right.
happy to see that.
Right.
But no, I just want to pick up on what Brian said. It's, to answer your question, I would encourage people to be curious,
Yeah.
critical as they think about this. Movies serve to inspire our imagination, but we shouldn't take things literally. And that's, movies are meant to be just that. They're meant to be fantasy, and they're great at what they do.
Yeah. And I enjoyed Interstellar.
Yeah,
And I did not sit around going, "Oh, okay.
Doing your
Right.
calculations.
I'm going to write to Christopher Nolan and tell him how he got everything wrong." No, you just have to accept the fact that it's not a scientific textbook, and that's fine.
Right, right. But have you been contacted for conceptualizing these ideas in movies or documentaries or something like? Do you work with them?
A little bit. Some of my colleagues, they tend to have go-to people that they want to go to. They're used to working.
Yeah.
Living in Los Angeles, it turns out, is useful. I'm guessing if Bollywood ever does this, being in Mumbai might be useful. But at this point, they have their go-to people, and that's fine. And so we don't all have to do everything.
Yeah.
And my sense is, given what they need, there's a whole range of people who can actually supply the expertise they want. Now, they went to Andromeda, they went to the man on that topic. Great. But the reality is, I probably could have told them most of what they needed to know for their purpose.
Okay, and so, but the thing is that it is hard to actually dissect out what is the fiction bit of it, what's the real bit of it, if you don't have the education for that. And for most of the school children, at least in India, they don't teach astrophysics in school, and then they learn about it in college, maybe some of the colleges, but it's not, again, very common, and there's a lot of gap. So we also lose a lot of talent pool that way in not being able to get that particular exposure. So how early do you think should the students start learning about astrophysics or astronomy?
I think the foundational topics in astrophysics are mathematics, physics,
Yeah.
a little bit of chemistry.
Yeah.
Those are taught very well throughout the school systems around the world, not just in India. Personally, I took just a personal interest in astronomy. I went to the library, The first book I picked out was Eva Novotny's Stellar Interiors, A Stellar Evolution. It should have driven me away from astronomy. It was a very difficult book. I'm not sure it's on the shelf here. But I met Eva many years later, and I said, I became an astronomer in spite of your book, because it was not the right book to pick up. But what I'd say to your question, Ambika, is I'm a big believer in self-study, in studying things that are beyond your school curriculum.
Yeah.
Not feeling trapped inside that board exam that's at the end of your school, looking beyond that, because that's the end of school exam or the end of college exam isn't the beginning and end of
Right.
the world. Things you study on your own are things you tend to retain for a long time. You turn the page when you're ready. You're not waiting for a teacher to turn the page when the class is ready. So what you learn. So my my message to students would be, if you're fond of a particular subject, doesn't have to be astronomy, astrophysics. If you're fond of a subject and it's not being taught in your school,
Yeah.
there are ways you can learn that, and that learning will be so satisfying because it's something you're already passionate about, and that's not something you'll forget anytime soon.
Yeah, I mean, I tend to agree. Astronomy is, I think, a useful hook
Yeah.
for people maybe to learn some physics and some math and things. We do tend to only talk about it in glancing ways when we're young. And that's probably appropriate. I think if you can get people to interact with astronomy, especially in years 1 through 6, it's quite an accessible way to start thinking
Yeah.
about just the whole notion of how science works. So there's some opportunities there, and that would be certainly in the Australian curriculum in that spot. But in high school, it's not clear. It's you kind of you probably it's probably not the right place to put it.
Right.
And as Raja said, lots of ways to learn. For example, I and a colleague of mine, Paul Francis, have done, a MOOC, a free MOOC that is available and that hundreds of thousands of people have taken, including lots of people from India. Now, it's at a pretty high level, so it's kind of meant for people in maybe year 12 who are good students, but it's out there, and there are other classes like that out there. So there's lots of opportunity. And as Raja said, it's really, I think, important for people to learn because they love, not because they're staring down a gun barrel at an exam, which they see as life and death.
Right.
So
Right.
the reality is that is a way that some people and some, like a lot of, I think, Indian students see learning. And I don't know, it's not my favorite way to learn. It's certainly not the culture I brought up learning.
Yeah. Yeah.
And I really want people to love what they're doing, not see it as a threat.
Yeah, I think it's a fair point. It's an important point for the younger generation. So for Raja, that you have been in the US since the early 90s, right?
Middle of the 80s.
Middle of the 80s. Okay. So when now you are doing a lot of things in India with students at different levels. So how did you come into it? Was that something that, you want to give back what you missed at that point, or what led to that?
There is some element of that. We are actually working with students around the world.
Yeah.
We are working with students in Africa, in Latin America, in many parts of Asia, including India. Some of this is really trying to engage high school students in research.
Yeah.
And for me, it's very much not about giving back, but about looking in the rearview mirror and reminding myself of where I was as a high school student. I remember that I had zero exposure to research at that age. And it wasn't just me. None of my classmates had any idea what science looked like beyond our textbooks, beyond our school curriculum.
Yeah.
And that was actually even the case through my undergraduate education at St. Xavier's College. It was a very sharp transition to grad school in the US, where all of a sudden I was part of a cohort of graduate students. I had never seen a research article. My my classmates had written papers already. So it was a very big divide. And I'm working hard to make sure that students who are interested in research in the long term don't face that kind of
Yeah.
gap, don't have that kind of cliff in there, that steeper learning curve. No, it's been very rewarding because much of what we do in astronomy research doesn't directly affect the human condition.
Right.
But this kind of thing, where engaging young people to think critically in whatever context excites them, has been a game changer for me. It's really made a big difference in my life. They engage in my research,
Yeah.
but they also engage in other people's research, and it's been wonderful to see that happen.
Okay. And what point for you, Brian, that you started thinking that oh, I should be an astrophysicist, or was it like a very informed decision, or this is by chance, or how did you choose that?
So I chose it my last year of high school
Yeah.
because I had always envisioned being a meteorologist, so someone who's studying the weather. And I went
Even
and
from before, like when you were a kid.
yeah, I love the weather from the age of about 5.
Yeah.
And so
Okay.
I was just obsessed with being a meteorologist. And so when I was 16, I
Yeah.
went through and called up the local weather service in Anchorage, Alaska, where I lived, and said, can I come and volunteer for the summer? And they said, okay. They never really had anyone do this before. And I showed up and they treated me really well. But I realized the forecasting office wasn't quite what I expected. It wasn't very scientific. It was a forecasting office. And so I had kind of figured I had kind of a vision of what I wanted to do. And this suddenly wasn't quite what I wanted to do. So I had to come up with something to do. And in the end, I said, well, I don't think I'll ever be an astronomer, but I like astronomy. And I know I'm going to learn math, I'm going to learn physics, I'm going to learn computing, I'm going to learn engineering. And those are useful skills, no matter what I decide to do in life. So I really went off to study astronomy, not to become an astronomer, but to study something that I would enjoy and therefore do well.
Yeah.
And I figured that would give me a career of opportunities. And I was exactly right. That's, in my opinion, exactly the way to go in to study something. Go in with open eyes,
Yeah.
something you want to do, and be prepared for things to take you any which way. And while I was there, I didn't just study astronomy. As I said, I took anthropology. I took 3 years of Russian. I
Wow.
did art history. I did English. Why? Because I was there to learn.
When you're talking about aspirations and game, one thing which comes to my mind is the outreach or the awareness that you both are trying to create in multiple ways using cricket. So I just I'm just curious to know what is the plan and what is cricket got to do with two astrophysicists sitting here?
Well, this is aspirational. We're not there yet. But when we were talking about coming to India, I was talking about one of my last trips. I traveled with Adam Gilchrist, the very famous Australian cricketer, and he's a big supporter of the university system, and he was here literally as part of a university delegation. And I was thinking, I actually once on the way down to Chennai was sitting next to Glenn McGraw and had a good chat with him about what he was doing here. And he was trained as a science school teacher. And we were going through and using cricket as a way to get people involved in science. I think the hope is maybe we can think about how to engage cricketers, Australia and India, to talk around science for our collective good.
Yeah.
That would be the aspiration.
Yeah.
So when I was growing up as an Indian cricket fan,
Yeah.
the cricketers you named, Brian, were the bane of my existence because they would be the ones thrashing the Indian cricket team, regularly, day in, day out. But yeah, I've been very fortunate to have some communication with Mohinder Amarnath. He was the man of the match for the 1983 World Cup semifinal and final. Remarkable player. I recently met Sunil Gavaskar. I spent an evening with him. I've been trying to get connected to Kapil Dev. So for me, growing up as an Indian cricket fan was associated with pain, the pain of losing, right? Because that you could be guaranteed that if you were an Indian cricket fan in the 70s or
Yeah.
the 60s, 70s, and
Yeah.
80s. But something changed in 1983 with that World Cup win. But what changed wasn't a one-off. What's happened in Indian cricket certainly since the 60s and 70s is there has been a diversification of the talent pool.
Right.
Indian cricket now draws from a much wider talent pool than it did back in the 60s and 70s. And one easy way to see this is in the level of English proficiency among the Indian cricket team. It's very common for interviews to be conducted in Hindi now. That was never necessary back in the 60s and 70s. Everyone spoke the Queen's English.
Right.
But what that meant was Indian cricket wasn't drawing from the full talent pool. And I'm convinced, if I look at it the other way around, the growth in diversity and the level of excellence, those things have gone hand in hand. As India has tapped into a broader talent pool,
Yeah.
the team has become a world beater. There are other factors, money, the flow of money into the sport. But, Brazilian soccer has done this, the NBA in the US. I mean, these are great examples of diversity in terms of tapping into the talent pool and diversity, DEI being essential to achieve excellence. And that's been a lens through which I've been looking at cricket of late.
Okay. What was something that stood out for you at Ashoka from the moment that you came until now?
Well, it's a new style of Indian university. I would say, if I, look at what Indians' future needs,
Yeah.
it needs a set of institutions that are, that cover more than just, engineering and science.
Yeah.
Which India has some very strong institutions in that space. And so, to my mind, you kind of need about 10 institutions that are really pan-disciplinary, that cover the arts, social sciences, and sciences, and provide what I would describe as a classic, well-rounded critical thinking background that is where ultimately leaders and all sorts of disciplines emerge.
Right. Right.
So it's kind of a pathbreaker there. It's great to see it. I knew of its existence, and it's good to see what it looks like on the ground. And I think the interesting thing for me will be to see it in it's 10 years old now.
Yeah.
To see it in another 15 to 20.
Yeah.
Because universities, take centuries to really get old.
Yeah.
My university is just turning 80 right now.
Oh, wow.
Which still means it's a very young institution. And I think it's really important. And I do see this needing to be the first of many such institutions for the country to achieve what it wants in the decades ahead.
All right. And Raja, you have been involved with Ashoka for some time and with the Lodha Genius program, particularly with the high school students through our partnership. So what do you think about one Ashoka? The next is about the program. What is that thing that stands out for you?
So I'm fortunate that this is my third visit
Yeah.
to Ashoka. And, Brian, you talked about your liberal arts education at the University of Arizona. I wish I had an education like the one Ashoka is offering when I was an undergraduate. I had the diametric opposite of this. I had studied 3 subjects. For all of college, I studied my physics and 2 minors, chemistry and math. And I wish I had a broader liberal arts education. There's critical thinking in a variety of subjects. I wish I had experienced that. Now, Ashoka has been amazing. I'm fortunate to have a dear friend who's at the helm of Ashoka, actually a couple of dear friends who are at various leadership positions here. The Lodha Genius program, you're drawing students from around the country.
Yeah.
And we've started this wonderful partnership both with Shadow the Scientist and with the Science Internship Program.
Now, I think we'll progress towards a little bit of understanding your personal side rather than philosophical questions or scientific questions. So one thing is there any book that either of you would recommend for people to read about space science? Not a technical book, but a book where a majority of the facts are right, and this is one good way of introducing space science to them.
I'm gonna start with a Carl Sagan book,
Okay.
which is um, Contact,
Mm-hmm.
and it was turned into a movie with Jodie Foster and Matthew McConaughey. Um, I love the story. We were talking about other space-themed movies and astro-themed movies.
Yeah.
I love that particular story. I mean, the the I would recommend that. I was very inspired by a somewhat more technical book written by Steven Weinberg called The First 3 Minutes. It's written like a movie, like frame by frame, early universe. That's a bit more technical because it talks a little bit about the physics of the early universe. But that pushed me over the edge of
Yeah.
wanting to be an astronomer.
Okay. Okay. Do you agree?
I'm going to go out of left field and go into physics.
Yeah.
There's this amazing book called The Making of the Atomic Bomb. And it's by Richard Rhodes. And it's really an account of the development of physics, modern physics, in the 20th century and how it intersected with World War II. And I think it, better than anything, explains the details of how science develops. And, it's kind of confronting because it ends up with the making of the atomic bomb. And I think the realization by the scientists that they were doing this, but they somehow thought they were in control.
Right.
And then they realized they weren't in control. And so there's some cautionary tales there.
Right.
To be
Right.
honest.
Right.
It's an
Okay.
outstanding book to read.
Okay, good recommendations, I guess. And one thing about Raja that other people might not know, that you're a wonderful painter and artist. So a little bit about that.
So I wanted to be an artist. I wanted to be a professional artist all the way through school.
Yeah.
Astronomy was nowhere in my on my radar screen.
Yeah.
It was really I wanted to do graphic arts. I wanted to work for an ad agency, design logos, and maybe I would have designed logos for for NASA and places like that. But it was a conversation with my grandmother, whose
Right.
art I really admired,
Yeah.
who didn't work outside the house. She was a homemaker and but did art as a hobby. She convinced me that I could do art as a hobby, science as a profession, but that I couldn't swap those two very easily. That if I decided to become a professional artist, I really couldn't do science as a hobby. She was probably right, and I followed her advice, and that's when it's around the same time that you became interested in astronomy, Brian. Around the end of high school,
Right.
I started to read astronomy books, and I went that route. But I still do art, but there's no pressure of paycheck or deadlines and things like that associated with it. So I really enjoy it, perhaps more because of those lack of those pressures.
Right. And your artistic side is with wine and vineyards. How did you get into that? And what do you actually do for the people who do not know the other side?
All right. So I and my wife decided when we moved out to a farm outside of Canberra that there was a perfect place to put a vineyard. So we planted 4,400 vines, and that sounds like a lot, but it's actually quite a small vineyard to make Pinot Noir.
Yes.
Why? I'm not sure why I did it, except for it was something that seemed kind of interesting and fun. I was into wine, and I don't know, it was just kind of a weird challenge. And my family, both my parents grew up on farms. I had spent my childhood with my grandparents on farms, so it was a chance to connect to the land.
Right.
And making wine is both artisanal, that you kind of use a bit of art, but there's also a fair bit of chemistry and science.
Yes.
So it's kind of a nice little blend. And for me, it's hard work. It's kind of a side hustle. It's hard to say it's actually a hobby given the amount of effort and money that goes into it. But I'm glad my paycheck does not rely on our winemaking because we've had a lot of bad, challenging vintages. And so it's nice to have a paycheck come in from being an astronomer first.
Right. I think a lot of lessons. So coming to lessons, what is that one lesson that you have sort of learned, in your career, from science or otherwise, that you would like to tell the others who's watching this podcast? Maybe it was a life's lesson which actually could have saved your life or saved your career, or it could be anything.
I mean, I've been very fortunate to be able to follow my heart. I love science, and I fell in love with astronomy purely out of deprivation. I grew up in a city where you couldn't see, I grew up in Calcutta where you couldn't see stars in the sky. So
Yeah.
my love of astronomy is really born out of deprivation of the night sky and going to the planetarium
Yeah.
and seeing what the sky might actually
Actually
look like.
Yeah.
But I've been fortunate enough to follow my heart both in astronomy and, in three things really: astronomy, education, and art. And my advice to young people would be to follow their heart, to not give up on their dreams. And it takes working hard, and the path is not always straight, but to not give up on their dreams.
And you?
Mine's very similar, as have confidence to do something that you want, that you love, you're passionate about, and don't make hard decisions
Right.
about that's not practical until you need to make them. And you need to be sensible and say, if you have a crazy passion that clearly is not going to
Yeah.
be a job, then be careful. But in my case, being prepared to think outside the box and say, I'm not doing astronomy for astronomy. I'm doing astronomy because I like it, and it's a tool to have a whole bunch of opportunities.
Right.
Have that confidence that life is full of opportunities, that there's not a right decision and a wrong decision. There are definitely wrong decisions, but there is a infinite number of right decisions, and every hand is ultimately, you can play as a winning hand.
Yeah.
And have that confidence that life will give you the chance to make the most out of the decisions you make. So have confidence in the decisions you make.
Yes, I think that's the right messaging right now at this particular situation. I think all the young people has so many life lessons from both of you. Whether you're also a winemaker or whether you're also an artist, it doesn't really matter. It's actually following your heart and have the confidence, stay positive, and then also sort of reflect yourself, I guess. So on that note, I think we've come to the close of this particular podcast, though I would love to host you for another few hours, but we know that we will not be able to do that. So thank you so much for having this wonderful and candid and honest conversation with me. So thank you for coming,
Thank you, Amrita.
Brian and Raja. Yeah.